Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the binary trees with factors problem. Given an array of unique integers, r, talk like a pirate, where every integer I is strictly greater than 1. We make a binary tree using these integers, and each number may be used for any number of times. Each non-leaf node's value should be equal to the product of the values of its children. Return the number of binary trees we can make. The answer may be too large, so return it modulo 10 to the 9 plus 7. Hey. Okay, this is a counting problem. This isn't a programming problem, this is a maths problem. Basically, 2 and 4 can obviously be singleton trees, but 2 is also a factor of 4. So we see here 2, 4, 5, and 10. These are all singletons. 2 is a factor of 4. 2 and 5 are factors of 10. And because they are distinct factors of 10, we get both orders. And I imagine if we had, say, 40 on here, we would have 4 and 10 other factors of 40, and 10 and 4 are the factors of 40, but those trees themselves can break down ad infinitum. Ugh. So what we need to do is, well, there's one way to make 2, and there's one way to make 4. But then 2 is a factor of 4. Do these come sorted? They always come sorted in the examples. But let's just be absolutely certain and sort them. So the idea here is there's one way to make 2 and there's 2 ways to make 4, so that means there's 3 altogether. There's one way to make 2, there's 2 ways to make 4, there's 1 way to make 5, there's 2 ways to make 10, 2, 4, 5, 6, no, there's 3 ways to make 10, sorry. 3, 4, 5, 6, 7, okay. Oops, this ain't JavaScript. So, yeah. Let's get our mod going. Just so we don't have to recompute that often. So for I val enumerate r, for j in range I, so if we're looking at the 2, we want to look at everything before it and see if it's a factor of it. So we're looking at the 2, we want to look at everything before it. If r if val mod r array j is equal to 0, no, that's not quite what I want. I think what I want to do is do a... No, what do I want to do? I really want the prime factorization of each of these. So 2. Well, no, the primes that make it up. I don't need the exact prime factorization, but I need the primes to make it up. So this is 2. In fact, no. So worked examples are always easier. So if I've got 2, 4, 5, 10, I want to produce the following set. 2, 2, 5, 2, 5. So then I look in the original set. Well, how many ways are there to get 2? 1. How many ways are there to get 2? But no, I want to go further than that. I want to also keep the 4. And I want to keep 10. So this is all the factors, including itself. 1, 2, 3, 4, 5, 6, 7. If those factors are in this set. So 4, if both factors are in this set. So for example, 15 here. 15, if we had a 15 in this set, this would have to just be a 15 because of its prime factors. No, of its factors, the only ones that are creatable is 5. We don't have the 3. This is quite a tricky problem, isn't it? Let's turn it into a set just for ease. Factors. Make that an empty set for for I, V, N, R. What we want to do is first create an empty set. And f star add v, and then for val and vals, if v mod val, if it's a direct multiple, f dot add val, f dot add v divided by val. No. We don't need that either. So we're looking at the 2. In fact, no, let me just finish this off quickly. So 2. Let's create an empty set for everything in this list again. 2 mod 2 is 0, so we add 2. 2 mod 4 is 2. No, okay, so that's fine. Sorry, I'm not talking very well today, am I? So I didn't need that as a set, so I removed the set. So the thinking is put them in order so that obviously if I'm looking at the 2, I don't need to search anything after the 2. So I'm looking at the 2. For everything up to the 2, which plus 1, for everything up to and including the 2, if it's a perfect multiple, add it to the set of factors that we know exist. 4. Everything up to including the 4, well the 2 goes nicely, so add that in, and the 4 goes nicely, so add that in. 5, 2 doesn't go nicely, 4 doesn't go nicely. This was V. 5, 2 does not go nicely into 5. Yeah, so 5 mod 2 is 1. 5 mod 4 is 1. Neither of those is 0, so we don't add anything. But 5 mod 5 is 0, so we add that. 10 mod 2 is 0. 10 mod 4 is 2. 10 mod 5 is 0. 10 mod 10 is 0, so those work. 15 mod 2. Ooh, there we go. Now that's more of a problem. Because what I need to do with the 15 does go nicely into 5. What we then need to do is check that val over v can be made using R. So that's a wrinkle. That's a wrinkle. If we can get this down, though, the answer is the sum of the factors. How can I check? Oh, but that's not correct though, is it? So hang on, no, I've been going about this completely the wrong way. So to make it 2, it's 1 ways plus all the ways to make everything that makes up 2. Well, that's nothing, but the 4 is 1 plus all the ways to make up the 2, which was 1. So here, 2 is 1, 4 is all the ways to make up a 2, plus 1, which is 2, 5, there's only one way to make a 5, 10 is all the way to make up a 2, plus all the ways to make up a 5, plus 1. Okay. But 15 is all the ways to make up a 5 plus all the ways to make up a 3. Now there's no way to make up a 3 here. But if this was, say, 80, this would be all the ways to make up an 8, and all the ways to make up a 10, and all the ways to make up an 8. Oh my god. Okay, that's going to get out of hand very quickly. This is recursive in some way. So I don't actually love this. Or even this example anymore, but so I want to keep the array.sort. And then it's counts is equal to, let's say, an empty dictionary. No, it's called ways to make. Yeah, no. Let's just make it purely recursive to begin with. Let's not worry about this at all. So for example, we're going to start with the ways to make a 2 given the empty list is 1. Oh, no, that's not correct. I'm going to start with 0. 2 given the list containing 2. For I v in array, if val mod v is equal to 0, now I'm a bit stuck here. I kind of understand what I want to do, but I don't, if you know what I mean. So I want all the ways to make 2, and then 4 needs all the ways to make 2 because its factors are 2. The factors that we have are 2. Problem is, these examples are not quite enough, are they? I'm going to give up on that for a minute. I need more information, I think. So obviously this is going to fail. The example test cases, but I also want 2, 4, 5, 15, and 2, 4, 5, 80. In fact, no, I can make that 40. Show me what I meant to get, please. 3, 7, 5, and 5. What? Oh, because I'm missing the 10. Eight and then 20. Because it's 1, 2, 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, I'd be way short. So 2 can be made using 2, 4 can be made using 2 and 4, 5 can be made using 5, 10 can be made using 2, 5 and 10, 40 can be made using 2, 4, 5, 8, 10, 20, 40. Am I missing any from here? 2's going to 40 20 times, 4's going to 40 10 times, 5's going to 48 times, 6's and 7's don't. So the trick is here, it's going to see, well, there's one, so I can make it 2. There's one way to make it 2. There's one way to make a 4. 1. Hang on. Let me do the next step. So here, this is 1. So this is 1, 1. No, hang on. Yeah, let's do these with ones that do not include themselves. There's one way to do that. There's one way to do this. So this is sum of the number of ways to make all of the elements in this list plus 1. This is empty plus 1. 2 can be made one way, which is 1 plus 1, which is 2. This is 1. There is one way to make it 2. There's one way to make a 5. 1, 2, plus 1 is 3. There's one way to make a 2. There are 2 ways to make a 4. There's one way to make a 5. We do not know about 8 yet, so we need to do a query about 8. We know there are 3 ways to make it 10. We do not yet know about the 20. Oh, but it's not plus 1. Or is it plus 1? Shit. I mean, oh damn. So to do the 8 breaks down into 2 and 4, which breaks down into a 1 plus 2 equals 3. So this is in theory going to be a 3, and the 20 breaks down into a 2, 10, 4, 5, isn't it? Which breaks down into a 1 plus 2. Oops, I forgot the plus 1. There's always a plus 1 on the end. And this breaks down to a 1 plus 2 plus 1 plus 3 plus 1, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, no, that one was a 3, but that one's a 4. So this one's 9. So 1, 2, 1, 4, 3, 9, 1. That's 10, 13, 17, 18, 2021. Oh shit, why are my totals too big? Okay, no, let's go more basic here. How many ways? So the array is 2, 4, 5, 10, 40. How many ways can I make a 2 using these numbers? One way. How many ways can I make a 4? 1 plus of all the factors of 2. Hang on. C2 is 1. C4 is 1 plus C2. C5 is 1. C10 is 1 plus all the ways you can make a 2 plus all the ways you can make 5 because so if we're building the tree for 10, it's either 10 by itself. No, this is a multiple. And it's doubled. Because we want to take all the ways you can make a 2 and pair them with all the ways you can make a 5. And then also flip the order. We didn't have to do that here because C2 and C2 we can't tell the difference. Oh, but that's so hard. So C40 is going to be 1 plus 2 times C2 times C20 plus 2 times C4 times C10 plus 2 times C8 times C5. Is that correct? So C4 here is 2. C10 is 1 plus 2 times 1 times 1 is 2, so that's a 3. This one is, I'm making a pig's ear of this by the way, 1 plus 2 times C20 plus 2 2s are 4 times 3 is 12 plus 8 and 5, that's 2 times C8. So now we need to go back here and work out C8 is 1 plus C2 times C4. But of course we can do that in either order, so that needs to be doubled. So that is going to be 1 plus 2 times 1 times 2. So 2 times that's 5. There's 5 ways of doing that. Is that correct? 2, 4, 4, 2. Oh, but 8 isn't in the list, so we want that to be a 0. At C20, we want to be 0 plus 2 times C. So hang on, so that's only 4 times C10 plus 2 times C4 times C5 equals C2 is 1 times 3 is 3 times 2 is 6 plus 4 and 5, that's 2, that's 4, so that's 10. So this is now 1 plus 2 C20s is 20, it's 12 plus 2 C8 is 8. No, I'm way over, way over. That's only meant to be 20. Not, what is that? 8, it's 41. I'm way over. How did I get so far over? I don't understand. I can make a 2 one way by using the 2. I can make a 4 two ways. Because of its factors are equal, it doesn't matter which side I do which, and the idea is that, well, it's the number of ways I can make a 2 plus, oh yeah. No, that's why I'm double counting so much. Is that why I'm double counting so much here? So when I'm making the 40, I can use the 40, or I can use the 2 and all the ways to make a 20, either side. No, why does this overcount? Or I can use all the ways to make a 4, all the ways to make a 10. No, I don't understand why this overcounts. Why does this overcount? Because the tree that makes a 4 on one side and a 10 on the other is distinct from the one that makes an 8 on one side and 5 on the other. Oh my god, I have misunderstood the question. Holy hell. Okay, that's why. I can't use a 10. Oh, sorry, I can't use a 20 because it doesn't appear. I have to use the nodes that appear. I can't, like, nest it. as such. So if I eliminate the bad cases here, so I can't use that. Get rid of the whole line. I can use the 4 and the 10 because they both appear in the array, but I can't use this because 20 doesn't appear. I can't use this because 8 doesn't appear. So this is 4 and 10. This is 2 and 3. That's 6 times 2 is 12 plus 1 is 13. And the sum of all of those is 1, 3, 4, 7, 13, 20. Holy hell. So this actually is kind of close. Oops. Not what I wanted. That one. Counts. So yeah, here 2. So the C is equal to 0 if val v mod v is equal to 0. One C. So here 2 can be made using a 2. That's it. If val over v is equal to 1, or val over v in array Yeah. So 4 can be made using a 2, so we find that. So the factors is the set containing val mod v, val divided by v, if len factors is equal to 1, in fact, no. Let's remove this check here and just start it at 1. So if this collapses down to a single value, C plus equals the counts of val mod v. So let's call that W. No, it's fine. Whatever. Else C plus equals 2 times counts val mod v times counts val into v. Now we've got to be a wee bit careful here. In fact, I don't need to do the 2 times. Because effectively I'm going to see the 2 and include it pairs with a 5, and then I'm going to see the 5 include it pairs with a 2. So that is okay. This one here, I'm going to see the 2, and I'm going to conclude it pairs with a 2, so normally I would multiply them together, but I don't. Ooh, actually I do still want to do that, don't I? Because, let's say we're doing 16. If we had 2, 4, 16, C2 is equal to 1, C4 is equal to 1 plus C2, and C16 is equal to 1 plus C4 times C4. Is that correct? Because we could do 4, 4. We could do 4, 2, 2. And we could do 2, 2, 4. And we could do 2, 2, 2, 2. Yeah, so that is... I don't actually want to do this check at all. That's all I need to do. Holy moly moly. Let's give that a test. See if we're even in the right ballpark. Oh, I didn't enumerate it. Oops. Rename some things, but not other things. It's going to be quite a long video. What? Val mod v. Oh, we know that's equal to 0. So that's not right. Ooh. No, hang on, I don't want that. That's what I want. And v in counts and val over v in counts. Hey, no. There's collections. I think that's what it is. I did mean default dict. I'm just being lazy here, and rather than creating my own thing that checks what the value is. For goodness sake. What is frantic Googling off screen? Just a moment. How do I use a default dict? Oh. I need to set to work with integers. That's slightly weird. Nope, we're working way over time here. Why are we outputting such high numbers? So 0, 2. Set C to be 1. Oh, I think that's how you do that. I think it might have been taking too much. Yeah, it was taking the keys as well. Excellent. So, let me just remove that monstrous comment there. We may not even need this, but stepping back for a second, looking at the problem we've actually managed to solve, we have effectively managed to count this iteratively. So all the ways I can count 2, well, looking at everything I've seen so far, there's only one way to do that, it's using itself. With 4, how can I do that? Well, 4 I can make with 2's. How many ways can I make 2's? Well, there's only one way to do that. So 1 plus 1 is 2. There's 2 ways to make the 4. So there's one way to make the 2, 2 ways to make the 4, there's 3 trees we can make all together. Same idea here, there's one way I can make a 2, there's 2 ways I can make a 4, there's one way I can make a 5, there's 3 ways I can make a 10, because there's one way I can make a 2 and there's one way I can make a 5, but there's also one way I can make a 5 and one way I can make a 2. So that's 1 times 1 plus 1 times 1 plus 1 is 3. So 3 plus 1 plus 2 plus 1 is 7. Oh, let's see if that works. Wrong answer. Oh, I didn't bloody... do the modulo. Made it. Forgot that final detail at the end. So that final detail about working modulo is so that languages like C don't panic effectively if you try and use a number that doesn't fit inside a 64-bit int. But it means that overflow isn't protected. It means we don't rely on any particular overflow behavior because he specifies the overflow behavior is work mod 10 to the power of 9 plus 7, he or she. Okay, that was quite a bit harder than I expected. But thank you very much for watching. I hope you found this enjoyable, and I will see you next time. Bye.